This time I'm gonna have you do your warm-up on an index card. On one side, I want you to write your name nice and big, and then on the other side, do the warm-up. Okay? It'll be a little bit of small handwriting there. I apologize, but I want this process. 1, 2, 3, 4, 5. Which sucks. There's a lot of people missing. 5, grab one back the back. 4. Let's see, 4. That one pass it back. I'm gonna give you a stack. Just help the students. And there. 1, 2, 3, and then. Cool. All right. So if you guys remember last week, we started doing synthetic division. And so we're going to keep doing that today. So for today's warm-up, we're going to do that again. So make sure you put your first name, your last initial. What's today? The 13. And here's your warm-up. I want you to divide the polynomial x cubed plus 8 by, I'm going to call this smaller polynomial dx, x plus 2, using synthetic division. Okay. So you might have to look at your notes to review how to do that. You're basically dividing this guy, x cubed plus 8, divided by x plus 2. If you were not here on Wednesday, try to work with a classmate, see if you can use their notes. And can I have you guys please put your phones away for right now? Yeah, just don't get distracted by the phone right now. Oh, Isabel. Let me do this real quick. Participation. You think you got it? Actually, from what I'm seeing right now, can I have you guys just check in with other people? Make sure you're setting it up correctly. Make sure you're setting it up correctly. That's what's important. Check that setup. Careful with those missing terms. Careful. Careful.
Yeah, I just figured like zero is that zero minus zero minus. Oh, I did that. Zero minus.
You got that last one?
Barrier. So I meant by itself. Alright. And then over here's where the quadrant is. You look at it. It's for one.
Let's see what you get. It's just literally copy.
Zero.
You can bring it up at work. This copy.
Plus.
You can take it.
Really. Go to powers.
Oh, I had this one.
So once you have all those variables in front of you, no, one,
Yeah.
zero, negative. And bring those over to the right. So we have one, which is the highest third, and then or the highest. And we have zero, I have another zero, for the two x's. And then you have. So for this. We're going to multiply by this.
All right, guys, so let's take a look. So let's see, so for remember, for a synthetic division, you want to write what makes this linear term 0, which in this case is -2. And then the trig part was what? What was the trig part here?
Negative.
The missing terms, right? So you want to think of this numerator as a degree 3 polynomial, so we want to think about it in its general form. So it would look something like this. There's an x squared term, there's an x to the 1 term, but we don't write the 1, and then there's a constant term. So there really should be 4 terms for a degree 3 polynomial. It only has 2, so it's missing the x squared, which is why we write a 0, and it's missing the x, which is why we write a 0. And then the coefficients of the constant term is an 8. The leading coefficient in front of the x squared is a 1. Cool. Drop the 1, and then we go ahead and multiply this one with this roots, which in this case is the root of this guy, -2. Give us -2. Continue that pattern. We add straight down, and we get that final result, multiply it with the root. Add straight down, get that number, multiply with the root. And then we add straight down. What did this 0 represent?
No.
That means it has remainder 0. There's no remainder. So it divides, this divides evenly. And then the answer that we use, that we get for this polynomial, is these are going to be the coefficients of this resulting polynomial. So that's why Eric put a 1 x squared minus 2x plus 4 for your constant. Do not use this guy here. This is the remainder. Right? Yeah.
How do you know to have x to the second power?
Because there's 3 terms. So this is the remainder. You know that this is going to be the constant term. This is a degree 1 with x. And then this is x squared, and then you're done. Yeah, there was 4 terms. You know there would be one more, x cubed.
The way that I thought it was gonna pound x squared is since it's factored, you have to like take an x out. Just kidding. Because when you put x squared, subtract 2x plus 4, and then x plus 2 parentheses like next to it, when you do those together, it's
This
going to give you x to the cube. Yeah.
Correct. Yeah. So that was part of, so what we did is I saw some people box this, and then, which is correct. That is that is the result of what you get when you divide this polynomial by this polynomial. But remember that this resulted in telling you that when you multiply x plus 2 by this resulting polynomial that you got here, it has, when these two multiply, what do they have to give you? The original f of x. So it gives you x cubed plus 8. And I'm saying that to go off of what you were saying, Clea. Yeah, so the result here, you know that when you multiply these, they need to multiply to an x cubed here. Where is the x squared? Where is the x? Through this FOILing process, those terms are canceled. Okay? And the reason we learn synthetic division is to help us figure out how to factor this guy here if we know one of the roots. Okay? No question.
So my question is the correct way to write this. We could do f of x equals this expanded form down here, or we could just write out the actual function equals.
Correct, yeah, so you can write it like this, or you can write the same thing and instead just say this equals f of x. Yeah. Mhm. Yes, they're both correct. Now, just to remind you of the main story,
The quotient in this case is x squared subtract two x.
x squared, yeah, this guy right here, correct. The main story of last week was we were looking for we have a polynomial. We're trying to figure out the x-intercepts, the y-intercepts, and all that, all the zeros and graph it. That's like the goal is to graph this guy. So when we're looking for zeros, here, this one's not that hard. We can set this equal to 0, minus the 8, and then cube root both sides. Okay, it's the algebra is not that nasty, but there's others where the algebra is very nasty and we can't factor it with the methods you learned. So we're doing all this other stuff to figure out how can I factor it in a different way. That was the goal, just to remind you, okay? Last class we said, well, if we know an x value that makes this function 0, in this case, -2 works. Okay. There was a theorem that told us there was a linear factor theorem that told us if you have a polynomial and you know that this x equals r is a 0, then it's equivalent to knowing that this function needs to factor. What should factor here if r is one of those zeros? It has to factor into a linear term where one of them is x minus r, and then some other polynomial like this. That was one of the theorems we learned last class. So if we know a root, though, that was the key. If you know a root, then we know that this divides by this factors into x minus r times some other polynomial. So like right now, we know that this guy factored into x plus 2 times another polynomial. So then we have to learn synthetic division to find that other polynomial. That's kind of the story, okay? Yeah.
So is that like on the website, there was problems like this, and then there'd be a third answer? What was, I didn't understand that.
Yeah, I explained that in class. So on WebAssign, if you did this problem, it said, oh fuck, I forgot what it said, but I think it said like to write it in.
You wanted me to write all together at the end.
Yeah, I wanted to do to write it like in this form,
Yeah.
Yeah.
okay? And I was saying that in that section, the synthetic division is a little more complicated, and there sometimes will be remainders that are 0, but I'm not covering that. So I said all the problems that you're going to do will have remainders 0. So this will just be a 0 always. And then this q of x is this result that you get. This d of x is the linear term that you have, and f of x is the function you're defining. Okay. All right, pass up your flashcards. Just put your name on your flashcard. If you showed up late, just put your name on the flashcard. No, I'm not collecting them. Any flashcards. Yeah, just the flashcard. Yeah, just put your name. Okay, I just want your name in the flashcard. Thank you. I forgot I usually do this in the first day of class and I have to blank in the flashcard. Pass what you have. Pass what you have. Okay. I'll collect the rest later. You guys will see how I use this. Alrighty, thank you. Okay, guys, so let's see. So we're gonna start with last class, we're assuming we know a root. Okay, so now we're gonna start with what if we don't know any of the roots? What can we do to start? Okay, so this is gonna take us to section 13.4 called a rational root theorem. So I'm gonna kind of quickly just write out a short version of what we said here. So last class, we learned that if f of x is a polynomial and x equals r is one of its what is here? One of its roots, then this function has to factor into x minus r times g of x. Okay. We then used synthetic division to find g of x. And so the main question is, what if we don't know any roots? Any roots to begin with? Okay. Right, because this relies on the fact that we know a root. Okay. Yeah.
Is there a reason it's called synthetic division?
What was the response we gave last week?
Expect division.
It feels like fake division, like not really looking like, it's like division disguised. Yeah. It's like a made up fake division. But it's really doing division. All right. So the answer to this question is the rational root theorem is going to help us. And this is what it says. So let's let f of x be a polynomial with integer coefficients. With integer coefficients, where let's say the polynomial looks something like this. Let's say it's degree n, so it's a to the n, x to the n, and then you keep going, you get a2x squared, a1x, and then a0. So it's some polynomial where the coefficients here, what kind of numbers must they be? They have to be integers. That means I can't have fractions as coefficients. Because remember, fractions are not all fractions are integers, right?
Does it say ration?
No, it does not. Rational.
Oh, okay.
Sorry, let me write that over. Thank you. Rational. Yeah.
We're rationing our roots.
Kind of, yeah. The roots will have to be rational numbers. Okay. So if this is true, right? Let's say we have a polynomial where the coefficients are rational, or sorry, are integer numbers. Then if there's a fraction, right? Let's say there's a fraction, is a root of f. So it turns out that there is a fraction that you plug in here and it makes the whole thing 0. Then there is a relationship between the numerator, denominator, and the leading coefficient and the constant number, okay? So if P over Q is a root of F, then two things are gonna happen. P divides the constant term, and Q divides the leading term, which is a surprise why that happens. And then the text provides a short little proof on that explanation, if you're curious about that. Actually, let's number them. Let's call this 1 and 2. All right, so let's translate this in English. Okay. So what is this guy saying? It's saying if you have a polynomial where the coefficients are integers, okay, and it turns out that one of the roots is a fraction, then that whatever that fraction looks like, that numerator will have to divide the constant term, and the denominator will have to divide the leading term. But only if this polynomial has a root that is a fraction. It might not be the case that this polynomial has a root that's a fraction. All the roots might be like, it could be complex numbers, it could be like the square root of 2, like they might not be rational numbers. So here's where you really have to use that knowledge we did that first week. What makes it a rational number? What makes something not a rational number? Okay, so the trick is, I'm going to give you a polynomial. Then we're going to consider all the numbers that divide the constant term, and then list all those possible numbers out, because those are all the ones that can divide the constant term. And then we're going to list out all the numbers that can divide the leading term. And then from all those possible P's and Q's, we're then going to create all the possible fractions, P's over Q's. And then we're going to check to see if they're roots or not. How are we going to check if they're roots? Okay, right there. Synthetic division. Okay. Let's see. It's going to be very time consuming. Yep. So here's the strategy of what we're going to do. Given a polynomial with integer coefficients, we'll list all the factors of its constant term, A naught. 2, list all the factors of its leading term, A naught. And then 3rd is use synthetic division to check which P over Q possible rational numbers, to see which P over Q possible rationals are roots. So as Cameron said, it's very time consuming. And I'll show you guys what this means here. It's one of those things where you just do it a couple times, and after you do it a couple of times, you're like, okay, I get how to do it. but it's just I have to do it a couple more times. Okay. So we're gonna use synthetic division. We're gonna do it over and over and over again until we find one that gives us remainder 0. Once we find one that gives us remainder 0, we know that f of x will have to factor in such a way, using that root, and then continue what we've been doing so far. Okay. Okay, so let's see. Watch. Here's an example. Determine if f of x equaling 2x cubed minus x squared minus 9x minus 4 has any rational roots. Okay. So when I think about it in this way, what's my a naught? What's my constant term? This guy here is your a naught. Okay, it's your or let's just call it the constant term. Constant. Which one's your leading term? Just the 2. Yeah. Okay. So this one's your leading term. So what we're gonna have to do first is list all the factors of the constant term. The first thing I gotta do is list all factors of, what's my constant term here? -4. These are gonna be all the possible Q's, all the possible P's. Okay, because we have to consider all the P's that can divide that constant term. So give me, just shout out some numbers. What's the most basic one that can divide the -4? 1. 1. What about -1? -1. So plus or minus 1. Plus or minus 2. Plus or minus 4. Those are the only, these are called the factors of this number. Okay, they're the ones that multiply to give you that. So these are all the possible P's. Okay. Okay, number 2. Now we got to list all factors of my leading term, which is 2. Those are going to be our possible Q values. So what can divide 2? Plus or minus 1, plus or minus 2. Okay. Therefore, what are all the possible P over Q's? Wow. Here, let me stop here. I want to consider all the possible fractions that I can get by dividing all these possible P's divided by these possible Q's. Yeah.
Kind of has to equal the whole number, right?
It does not have to equal a whole number. It can be a fraction. That's why it's called rational, because it has to do with fractions. So you want to consider all possible fractions. It could be a whole number though. Like what happens if I have +1 divided by +1? 1. What happens if I have -1 divided by +1? Notice that no matter what kind of combination here, I'm going to get 1, but it's going to be plus or minus. Is that cool? So if I divide that, I'm going to get plus or minus 1. 1 over 1, I can think of it, but that's just 1. What about 2 over 1? Plus or minus 2 over plus or minus 1. What are the possible things I can get from that?
Plus or minus.
Plus or minus 2. What about the 4? Plus or minus 4. And then now I bring in the other guy. Plus or minus 1 divided by plus or minus 2 can give me what fraction? Plus or minus 1/2. Plus or minus 1 divided, is there another fraction you guys can think of? I guess 2 over 2 would be just 1. So can you guys, is there any other fraction that I can get that I can add to this list that will produce a new root to this list? Yeah,
Doesn't matter how many times it can happen.
it doesn't matter how many times, it just matters if it shows up or not. Because this theorem says, if it's a root, it must do this and that. And these are all the possible fractions that satisfy this part here. What about 1/4? Is that an option? No, right? Because if it's 1/4, then that 4 would be one of these q's, but 4 does not divide 2, right? So it's always gonna have to be p's over q's. All right. So now, what's the next thing we have to do? Synthetic division to figure out which of these 1, 2, 3, 4, 5, 6, 7, 8 is a root. Possible option. Okay. So, let's start with one of them. Let's start with, which one do you guys want to start with? One, let's start with one. Okay. So synthetic division, so we're gonna use synthetic division to see which x over p over q gives you remainder 0, which will then tell you that it's a root. Is a root. And so you guys said, let's start with just 1, positive 1. What's the polynomial we're dividing? Exactly. So that's what, those are the coefficients you're gonna list here. So 2, what is that? -1, -9, 4. And then you guys just do what you did on your warm-up. Bless you. You bring down the 2. 2 times 1, 2, add straight down, 1. 1 times 1 is 1, add straight down, -8. -8. Not a root. Does not give you a remainder 0, so x equals, just use both. So x equals 1 is not a root. Okay, so +1 isn't gonna work. So then let's try -1. It's -1 could be the one. Repeat. 2, -1, -9. If you're a computer science major, think of like, well, how would I code this? Just do it for me. Input blank. Output remainder. All right, repeat. Bring down the 2. 2 times -1 this time. Add straight down. This is going to give you hella synthetic division practice. -3 times -1 is +3. Add straight down, -6. Multiply with -1. That gives me remainder 2. Nope. I want remainder 0. So x equals -1 is not it. Is not a root. All right, I want you guys to find the one that's the root. Keep going. Here, I'll give you guys a hint. Start from the back. That's my hint. Start from the back. Okay? Start from the back. And don't forget, I'm just a messenger. Yeah. The math is the math. This is true. And I just realized I haven't assigned your homework. So I do that. So remember, my hint is start from the back of the list. Okay, work your way this way. That's my hint.
And what X is zero.
You want eventually to have a remainder 0, which will guarantee that is actually a root of the original polynomial.
You need more than one, you can still come behind it.
All we need is one. All we need is one. If you find 2, that's good, but all you need is one. All you need is one. Anybody find it? What is it? Negative 1/2? Let's see. Negative 1/2. 2, -1, -9, and 4. Let's see. Bring down -4. Thank you. Bring down the 2. 2 times -1/2. -1. Add these to give you -2. +1, which gives you -8. Oh, they're all even. Oh, okay, that makes life nicer. -8 times -1/2. It's +4. Boom, remainder 0. Okay, so this tells you that x equaling -1/2 is a root. Therefore, like you guys did on the warm-up, what does that tell you about how you can factor this polynomial?
Plus one.
X minus this root, which is really going to be plus, good. 1/2 will multiply with -2x and then 2x squared. So that's how you know it'll factor into that. Okay. Now remember, that was the whole point. Once we know what to root, boom, we can factor it like this. Okay.
Oh, yeah.
And then that's exactly where I'm going to now. Okay. Back to the original question. If I gave you this on the test and I said, find all the x-intercepts, find the y-intercept, find the sign chart, blah, 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 like the whole shebang, you would be stuck finding the x-intercepts because grouping would not work in this case. So there would be no way to factor it from the factoring techniques we know. So therefore, I don't know yet. I might just say on the test, you know, find a root first to help you. Hint, find a root. Okay. And then you're gonna be like, damn it. I have to do all this. But then now that you know how to factor it, now it's factored. We know how to find the 0 of that. And you know how to find the 0 of this, even if it doesn't factor. What can you use? You can use a quadratic formula. Okay. Okay, so let's see. So let's. Oh,
We
Question.
still have the page in that some for the test.
yeah, you're still allowed a page minutes. Questions? About how we got started? Okay, so let's see. That answered this question. Here's example number 2. Example number 2 says, find the y-intercept x-intercept. And use a sign chart to graph f of x equal 2x cubed minus x squared minus 9x minus 4. So this is what we did last week, okay? Well, let's review something. So let's see. So y-intercept. How do I find the y-intercept? Somewhere there's a zero involved.
Plug in zero to the variable a.
Plug in 0 for x, which eliminates that, and it leaves you with the constant -4. So what's the points that we get?
0,
X is 0, y is -4. Okay. X-intercepts. What do I need to do to start finding this guy here?
Set it equal to 0.
You're gonna set the polynomial equal to 0. This is what I'm just pretending I'm doing this on the exam. Okay, so I know how to find the y-intercept. Now I gotta find the x-intercepts. So I need to set the function equal to 0 and solve it. This is where you would get stuck. Okay. I can't do grouping. I can't do nothing to help factor this. So what you would have to do is go here and start finding a root. Blah 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 blah. You find a root. Now you know how to factor it. Let me show, yeah. Just kidding. Sorry. There is no 2 there, right? Yeah. Thank you. Thank you. You guys get what I meant by here? What you would have to do? You can't factor it, so I need to use all these theorems to help me find a root. I found a root. Now I factored it in this format. So we know from there, from that work, that this factors into x plus 1/2 x squared minus 2x minus 8. Oh wait, don't want to erase it. What makes this equal to 0? Negative 1/2. And then you set this guy equal to 0. Any suggestions on what we can do here to get started?
you can pull it 2 out.
You could take a 2 out. Yep, you could definitely take a 2 out. And that leaves you with x squared minus x minus 4.
Yes.
Okay, and then I go, please, can this factor? Let's see. If it factors, I need 2 things that will multiply to -4, but add to -1. Are there 2 numbers that multiply to a -4 and give me an add up to a 1?
No.
Nope. So it doesn't factor. And it doesn't factor into nice whole numbers here. But what can you use? Help me do that real quick. So use a quadratic formula to find the zeros here. See, this is a good review for the test, so it's like it's making you guys review all the quadratic stuff. So use a quadratic formula
It's making
to find these guys here. What are your coefficients that you're going to use? What are the coefficients? What's your A, your B, and your C?
1, -1, -1.
And -4, perfect. So use the quadratic formula. The notes that I'm gonna post show all that work, okay? But I want you to do that. You can review. Taking college level math, baby. So maybe that's something you guys want to put in your note sheet, is a quadratic formula. Here, we'll show in the video, but just so you guys can start. This is your quadratic formula right here, okay? Quadratic formula.
How did people discover something this specific?
There's another way to solve quadratics called completing the square, which I haven't covered yet. It uses that to get that formula. Mhm. Yeah, so try to write out your roots for this quadratic expression. Simplify as you can.
Is this stuff gonna be on the test?
Is this what?
It's gonna be on the test.
Sorry, say it again.
Is this specific section gonna be on the
Yeah.
test? Is Wednesday where it stops being on the test?
Correct. And for 13.4, this is it. I mean, we're gonna do more problems, but this is like the essence of it.
Section 4.7 gonna be on the test?
That's the last section. We're starting it today, finishing it off Wednesday, and then doing an exam review. Check, you should get, is it 1 plus or minus root 17/2?
Yes.
And actually,
You can't really change much after that, right? Because 17 doesn't really split out of the square.
yeah, no. Actually, let me do this, guys, so. We're just gonna answer this part for now. This part. We'll continue that later. Yeah. So there's the plus version. And there's the minus version. Can you guys help me here? Round this to a decimal. Someone with a graphing calculator? Or a very smart scientific one? Is it, is it 2.6? No. I should, around 2.6. And if you do minus, it's negative 1.6. Close to negative 1.6, if you use the quadratic formula. So this tells you where you're going to cross the y-axis. This tells you how many times do you cross the x-axis? At each root, right? At negative 1/2 or negative 0.5. At about 2.6 and at about negative 1. That's where your graph's on the prospect. Okay. I don't want to erase this work here, so let me see, okay, I'm gonna leave this here and I want it to show up on the notes. I'll write it better in a little bit, but right now, just so that it shows up on the video. Okay, so I would like you guys to. So for
But -16 or -1.6?
-1.6. -1.6. Sorry, can you guys see it back there? Yeah. Okay, what I would like you guys to do is just focus on this part. We'll get to this stuff in a little bit. So let's just focus on this rational root stuff. Because that will eventually help us find this type of information like we got here. So what I want you guys to do is determine. How do I write it here? Determine if f of x equaling 2x cubed minus 5x squared minus 3x plus 9 has any rational roots. X equaling p over q. And then just, maybe you guys can divide and conquer with your classmates? They check one root, you check the other? Or you could do it alone. What? I'll leave that up to you guys. Do some divide and conquer. Here, your constant term, 9. Leading term is still 2. You gotta find your P's and Q's first. Okay? You guys here checking with each other? Okay, this club right here is checking with each other. You 4 guys, maybe check in here. Laura, Esther, yeah, so then I'll have you bring your. And then you guys clump up here.
Okay, but you're taking 2 on.
Check in your.
Plus or minus
check with
1,
each other here.
minus 3, you guys can have a fucking.
Commission.
1 and 2.
You do about 1/2.
I highly advise you divide and conquer. Highly advise that. So you don't feel too overwhelmed.
The possibles. Yeah. And then just do this. That's all.
We're working on that. And you're basically gonna repeat what we did here. And that was highly advising you guys to divide and conquer. Like one person does one root and do synthetic division to eventually find the one that the main user.
What is 4.5 spread? You do.
1 over 2.
Wait, Aaron, did you do 1 3?
But like,
Whatever.
What over to?
Okay, I'll take. They're just doing these one, yeah, and three. One half. Yes, so it ain't.
If you found it, go ahead and check it out the group.
I'll find back because
One of those things. One old-
Well, because you have to do one. Not. So that would be the question. So we box that. So what you said?
No, his face.
So when you think about it, you isolate it out, you get that box. It wouldn't make sense.
No. It's not.
But it would help to do it with one half.
Okay,
You know what I'm saying?
yeah, so just the fact that he was. Whenever mind.
I don't think mine's very funny. This one's the plus minus not really the plus one. Oh, that's plus minus. Plus minus not. I would say nine.
We got all.
Well, it's fine. But it's something like.
Help each other out. There is no help.
Yeah.
Help each other out. There should be 12 possible things to do. 12. Because of the plus or minus. So, yeah, 6 values, but like all plus or minus.
Are we gonna be able to divide it on?
You will not, I will make it so that it's something.
You'll have like everyone avoiding that problem till the end. I can still have one time to finish it.
Yeah, and this one would be, this one would be hard because of how long it could take. Hopefully, these are all the possible P over Qs. All these are the possible P over Qs, okay? There's a whole bunch of them. Found it?
Yeah, so it has.
One group has found it.
Algebra.
Let's do it.
It's like, I'm doing. It's like.
It's a fraction one. The one you're avoiding.
Yeah.
And it's a fraction one. These are all the possible P's over Q's.
Go.
Two should not be there. No.
So you want to look at so it's just 1.5. I'm good. It's negative. Positive. So what do you do? You know after that. You don't know yet?
Oh, wait, well, this, mine I know where two is.
But that's P over Q, right? Right now, you're just listing like this first part. This first part just lists all the possible P's.
Yeah, but back to the negative, right?
Yeah. So for this one, you would just list all the factors of 9. So 1 plus or minus 1 plus or minus 3 plus or minus 9. That's it.
Yes, well, maybe negative.
So for that first list,
Negative.
We just did that one.
these should not be because only these are the ones that can decide. It should only be these.
So possible, you're saying it's
Yeah,
not all.
that looks wrong, but I could have missed it together. It's like one.
It's no, it's all the combinations where you have one of these over one of these. So notice that I don't have 1/4 here
I see.
because the 4 is always going to be on top of one of these two.
Okay.
You guys find it?
Yeah.
So basically, we're only do one over.
I'm sorry.
Oh.
Yeah. No, it's mine's. But I think if you start knowing, it's not gonna add up on the second story.
I did the same thing.
Yeah. I'm also going but it's.
What's the root? You guys find it? What's the root? 3/2. If you haven't found it yet, confirm that it's 3/2. Maybe they got it wrong. Confirm. Was that the only one that you guys found?
Yeah.
Oh,
You only need one. It's okay.
yeah. I've seen that.
Wait, is there another?
I don't know. I didn't check. I think I only did like 6 of them. And then I was like, I found it. I had to struggle with myself so that I understand how long it would take to guess. All right, guys, you guys deserve a break. That was some hard work. So if you haven't found it, the root should be 3/2, positive 3/2. But that's pretty much what this section will go. That's what it's covering. Okay, how to find those rational roots. There's more, but we're to stop there. Let's take a break. When we come back, we're gonna answer all of like the whole thing for this polynomial. Y-intercept, roots, end behavior, sign chart, graph, the whole shebang. Okay? So come back. Let's restart at 2:02. Go ahead. Get some sugar inside you. Come back at 2:02. Even though it feels like it's because we went an hour forward, right? Yeah. You're a little beat right now. I understand. It's good. All right. So this little practice problem that you guys did here, I rewrote it over here. Okay. We're gonna reference it. So it's the same problem you did, but I just rewrote it here. You guys found that the root was 3/2, right? So that tells you that this polynomial f should factor into x minus 3/2. And then these coefficients give you the quadratic, 2x² minus 2x minus 6. Okay? Okay. So now let's do the grand finale for this problem. And we're gonna answer the whole thing here. So example 2. So find the y-intercept, x-intercepts, and use a sign chart to graph the polynomial, which is going to be the same one you just did, 2x squared, 2x cubed, minus 5x squared, minus 3x this line. Recording again. Yeah, so let's do everything. Okay, let's see. Here we go again. So y-intercept, let's start with the easier one. You want to intercept? Plug in the 0, gives you 0, plus 9. And then you have the 0.09. X-intercepts. The hard ones. This time you set the function equal to 0. Can we try factor by grouping? Nope. That won't help. Nothing helps. So you have to do what you just did. Find that root, helps you factor it. Okay. So through this work that you just did, now we know that this polynomial factors into x minus 3/2, and then 2x squared minus 2x minus 6. What's the root for this bad boy? 3/2, the one you found, this guy. And then for this one, like we did earlier, you set that equal to 0. Anything factor out? 2 factors out. What's that? X squared minus 3. Okay. And that will not factor. You got to use the quadratic formula. I know. Let's do that one together. We got to use the quadratic formula. A is 1, B is -1, C is -3. So if I use the quadratic formula, I'm going to get -1, +1, plus or minus -1 squared, minus 4 times 1 times -3, all over 2 times 1. Is that correct? A little close to the board. Okay. We just got to clean it up a little bit. So it's 1 plus or minus, what's that, 1? -1 times -1 is 1. -4 times 1 times -3 plus 12 over those 2. So we get 1 plus or minus root 13 over 2. Ooh, no wonder it didn't factor. Some ugly decimals. But that's the zeros. We actually have to find the x-intercepts. Okay. So one of the x-intercepts is 1 plus root 13 over 2, comma 0. And then the other one is the minus version. Did I look up the decimals of that? Let's see. Yeah. So this here is about close to 2.3. You put that on a calculator. And then this one is approximately -1.3. But now we know it crosses the x-axis at 3/2, 0. And at these 2 other ones. So it crosses 3 times. Questions? Eric?
Could we leave it in the square root form?
Totally. You can leave it in the square root form, but when it comes to graphing, you got to know where it's going to cross, right? So that's why I'm putting that back there. Good question. Okay, guys, so let's see. What's the end behavior? That's it. It's a big old review for the test. And behavior. What about the polynomial can help you determine that?
The exponent 3 is odd.
Odd?
I know that.
Yeah. So you want to, for this guy, you want to look at the leading term. 2x cubed. Degree is odd,
Yeah.
and the leading coefficient positive. So if you guys, hopefully you put it on your note sheet. Figure out what the leading, the end behavior, what do the tails look like as I go to the right?
So,
Up, and then
Down.
down. We don't know what's in between. All right, now let's make our sign chart. Here's my x-axis. Where do I start making my divisions here, my separations? At the x and and 3/2, which is 1.5. So let's say here's the y-axis. So we got, oh shit, hold on. No, don't draw it there. Say it's more right here in the middle. So we got 1, 2, 3, -1, -2, -3. And then we have to approximate. Let's do positive 1.5. So we know it's going to go right here. 1.5. Positive 2.3. It's about like right here. And then negative 1.3. That's about right here. And so then remember, we're going to kind of partition this. And then what did we do? Plug in some test points. So what is a good test point to use on this side?
-2.
-2. So we'll do that. Let's do -2. And then what's a good one between these two? 0. 0. What's a good one between these two? 2. Yeah, that's a good one. And then what's a good one after this one? 3. Oh, a lot of work. Doing that? It's a little warm in here, I apologize. Oh, man, okay. Let's see, we plug in -2 here. A lot of work, huh, guys?
Yeah.
Look. Okay, let's see, if I plug in this guy here, it's gonna give you. Did I do this already? Oh, okay, thank God I did it, okay. So I already calculated this for you guys. When you plug in -2 in here, you're gonna end up with a negative. When you plug in 0, we got 9, which is a positive. When you plug in +2 here, we ended up with a negative. And when I plugged in 3, I ended up with a positive. So that means, let's see. For this part here, the graph has to be above or below the x-axis.
No.
It has to be below, so it cannot be in this area here. And then in this section, f of 0 is positive, so the graph will have to be above. So we do not want it to be below the x-axis. in that small skinny region there, the y values have to be negative. So it cannot be above the x-axis. And then positive, so then it cannot be below. Where does it cross the y-axis? At 9. So then finally we put all this together. Woo! And behavior starts from the bottom, which matches with what we have. So it's gonna have to go up, crossing somewhere here, and then what happens after this part? It has to stay below, right? But then has to twist up and go like that. Does it peak at 9? Does it go up here and then it drop down to 9? We don't know. We don't have enough information for that part. We just know it has to cross at some point there. Okay. Whole shebang. Man, this problem, like from the beginning, it's like a 20-minute problem. There's all this that was done from here to here. Yes.
But not this complicated.
I hope not.
I will not do one that gives you this
Yeah.
many options. That's gonna take way too long. It's gonna take you the whole test.
That's a different test. It's gonna be a pop quiz with just one with 20 different options.
No. Questions? You tired? Yeah, let's look now tired. Do you guys want to try one on your own? Or do you want to try, or do we move on? You want me to just show you the other ones here on the notes? Okay. The other one is basically, we do this again, and then you do all this again. That's what the other one is. Okay? Okay. I don't think we'll see a theorem for a long time now. So we're good with theorems for now. All right, so we've been dealing with halopolynomials, rational functions, fractions of polynomials. Okay? But there's not as much crazy madness as what we've been doing here. All right. Let's see, section 4.7. I think we're gonna need another little mini break in between. Rational functions. We'll start with kind of defining what this would look like. So we're going to say a rational function is a fraction of two polynomials. Normally written like this: f of x equals p of x over q of x. This p and q have nothing to do with the p and q we just discussed, okay? It's just it's the notation for that. Okay, so we're gonna play. I'm gonna show a lot of Desmos in this section. So consider the rational functions. I'm gonna show you three. You're just gonna look at them right now, just kind of play with them and observe what they look like. What we're gonna call f of x to be negative x squared over x minus 2. G of X is going to be X minus 4 over X minus 2. And then H of X is going to be 6 over X minus 2. Oops, minus 2. For all those functions, what does the denominator tell us about the domain? We cannot plug in X equaling 2 because then we get 0 in the denominator. So for all these, all 3 of these, 2 is not in the domain. That's the only X value that's not in the domain, okay? But I want to show you what that looks like what that results in the graph. So let me pull this up. And it's just kind of, right now we're just doing more of exploration. I'm going to show them back up here on Death Notes. Give me a second. Okay, so here's f of x. So notice that at x equaling 2, let me do this dashed. The real graph looks like this, okay? But I want you guys to notice what happened to the graph at x equals 2. It doesn't touch it. It's like kind of like where the graph, it's like a barrier, right? And I want you guys to notice the blue graph. Does it ever actually touch where x equals 2? No, it looks like it, but it just keeps getting closer and closer, but it will never really touch it. Okay, it can't touch it because if it touched where x equals 2, then there was a point on it which you plugged in 2 and it gave you a y value, but that can't happen because 2 is not in the domain, so it can't touch x equals 2. Okay, so that's f. I want you guys to look at the tails in this case. What happens as x goes towards infinity? F of x is doing what? The y values go down. They're getting negative. So in this case, as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to positive infinity. It's going up. All right, let's take a look at this guy here. Here it's a little different. Notice that at x equals 2, the graph's still breaking apart and it's still getting really close to x equals 2, but it never really is touching it. Okay. So it kind of did the same thing the other one did, but look at the tails in this case. As x goes to infinity, what are the y values seem to be doing? They're increasing, but are they shooting off to infinity, increasing like crazy? It turns out that no. They keep getting closer to, watch, let me plug in g of 1,000. See, if I plug in 100, it's about, y is about 0.98. If I plug in 1,000, that y value is getting close to 9.99. And if I just keep making x bigger and 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 bigger, it's eventually approaching the y value 1. Okay. And so in this case, this is where this is different from a polynomial. The tails of a polynomial will either always shoot up to infinity or down to negative infinity. But for this guy, for these rational functions, that's not the case. They can be what's called bounded. Okay. The graph, yes, it is increasing, but it's being bounded by the y value 1. It gets closer and closer to 1.
So why is the separation point?
So y equals 1 is this, it's like a different separation point. Yeah. But it's getting closer to it. Okay. It's getting closer and closer and closer to it. So in this case, we're going to say as x goes to positive infinity, f of x is approaching 1, not infinity. It's approaching 1. Okay, exactly. So f of x arrow the number 1. Yeah. Okay. We're gonna call these kind of bounding things that the graph is getting closer to. When it goes straight up, this black line here, we're gonna call that a vertical asymptote. So in math, when you hear the word asymptote, it's kind of like a kind of a line or a curve that your function's approaching, that it's getting closer to. Okay. So vertical because it goes up and down. So then the blue one, we're gonna call it horizontal asymptote. Okay, yeah.
So when finding the horizontal asymptote,
Mm-hmm.
it seems like it's just with the dominant fractions in a sense. I mean,
This guy right here.
yeah. Well, I mean, that's like the correlation.
Okay. When do you mean vertical or horizontal?
Horizontal. Or well. No,
I think you meant vertical. Yeah. Let's see. What do you guys think if instead of -2, I put -5? What do you think is going to happen to the vertical asymptote? Let's see. Notice that now it's going to be at 5. What if I do +5? It's going to be at -5 because now -5 is not in the domain. So there is a correlation.
So,
Yeah.
how do you find the horizontal?
That's a great question. Yeah, we're getting there. We're getting there. But yes, but exactly. So the point of this, kind of like the polynomial, is can I just look at this rational function and are there key parts of it that will help me compute or help me determine what the asymptote should be? Yeah. Mhm. Oh, interesting. Versus when it was -2. Like this part, the green part here was on top, and then this was on the bottom. Is that kind of what you mean? Oh, yeah, you're right. You're right. Mhm. Well, we kind of look the way you guys did a sign chart. A little bit of that will play a role too. Okay, let's look at the last one. Actually, go back to the first one. Do you see how the tails go to infinity or negative infinity? So there is no horizontal asymptote because they just shoot off up and down. Now let's look at the third one. The third one also has a vertical asymptote at that same x -2, or that 2 here. And in this case, let's see, let's plug in big ass numbers for x. 10, 100, 1,000. So as x is going to infinity, oh man, it's not going to show it to you. What do the y values seem to be getting closer towards? They're going to get closer to 0 in this case. So in this case, your horizontal asymptote is not at 1, it's going to be at 0. Your graph is approaching that line. Okay. Okay, so here, let's just sketch these real quick. In your notes. So this guy here. X equals 2. We had a nice little vertical asymptote in there. But the graph itself, it crossed here at 0, 0, and it did this funky shape like that. And then it just shot off in this direction. And then over here, it did this like curving thing like that. Oops. Sorry. This one also had an asymptote at 2, but then we saw I had a horizontal asymptote at 1. And then the graph, and then this thing like that. And then on the bottom, And then this last one here. Two again. And then this time we saw that the horizontal asymptote was at y equals 0 there. And in this case, what is this? So let's start figuring out how to find the things that every function seems to have, which is y-intercepts and x-intercepts. Okay, so let's look at y-intercepts first. How would I find the y-intercept here? What have we been doing to find the y-intercept? You plug in 0, same thing. Just plug in 0, plug in 0. You get 0 squared over 0 minus 2, which is 0 over -2, which is just 0. So that's the point 0, 0. And that's why that point right there is right here. We're across it right there. For G, we do the same thing. Plug in 0. Here, be careful. 0 minus 4 over 0 minus 2. It's -4 divided by -2, which is 2. So now that tells us that this graph, see how it crossed the y-axis right here? Where does it cross it? 2, it has to. Because of the work that we just got. And then for H, plug in 0. That's going to give you 6 divided by -2, which is -3. And that's why that graph was crossing down here. 1, 2, 3. Okay, x-intercepts. I'm gonna have you guys try this one because I've been doing too much talking. I'll help you get set up though. For x-intercepts, what have we been doing to the functions to find these guys? Setting them equal to 0. So for this guy, if I want to find the x-intercepts, I set that guy equal to 0. So that's going to be -x squared over x minus 2. For G, I do the same thing. I set the G function equal to 0. And for H, I do the same thing. I set 6 over x minus 2 equal to 0. And now you have to solve what's called a rational equation. I want you guys to do it. So solve each 3 of these equations. See what happens when you solve. Whatever algebra tricks you guys remember. Check with your group. Once you find it, label it on your, see, like this one we know has an x-intercept here. Where is it? Here seems to, make sure it makes sense with the picture. Whatever you find. Use the knowledge of your group, work together. I'm not sure how to start. What's up, dude? Which is this graph this graph? It should, because of this is right there.
Oh, yeah. Just too easy to.
Yeah, it does cross.
Okay.
When did you guys start solving it? What was your first algebra step? Multiply both sides by what? X minus 2. All right, nice. Multiply both sides by x minus 2. It'll cancel off here, and then you end up with this times 0 is still 0. Now you just end up with that. How do we get rid of that negative? Multiply to the other side, divide by -1, either one will work. So then again, you get 0, x squared, and then you took the square root. But what's the square root of 0? 0, plus or minus 0, 0. So this tells you that you have an x-intercept, again, back here, back where you had your y-intercept. Okay, so yes, that's matching, right here. All right, here you do the same thing, multiply both sides by x minus 2. You could have also just cross multiplied. That's another way of doing that. You end up with 0. Here, this cancels with x minus 2. So then we get x equals 4. So your x-intercept is going to be at right there, 2, 4. Now we know that it crosses for sure at 4 right there. Here you do the same thing. And we end up with 0 equaling 6. Uh-oh.
I mean, there's no correct.
Yeah, remember, whenever the x's cancel, but you don't have equality, tells you there's no solution to this equation. Which means? So which means no x-intercept. And that was because the graph was approaching the x-axis, it just never crossed it. Okay. All right, let's take a 5-minute breather. You guys partied hardcore this weekend. I don't know what happened. Okay, I think it's the weather. It's a little humid. So take a 5-minute breather. 2:45. Daylight savings time is definitely what happened for sure. Yeah,
It's totally blame.
yeah, let's blame it. Not the party. The study. Yeah, let's take a little baby breather though. Okay, so for this guy, we still use arrow notation to describe the tails of the graph. The difference between rational and polynomial functions and polynomials, right? Let's say the difference between rationals and polynomials is that a tail can now approach a y value. So it's not just positive or negative infinity. Okay. And so let's practice that again. So let's say I want to describe this tail. We're going to start by describing it with x. If I want to describe this part, what are we going to say x approaches? Infinity. As x gets bigger, what are the y values doing?
Getting closer to the working.
They're going down. So we're going to say that it's approaching negative infinity. As x goes to negative infinity, so now we're looking at this tail, as x goes this direction, f of x is doing going up. Going up. Okay. Let's do this one here. Now here's where the new stuff comes in. As x goes towards positive infinity, what did we notice the y values were doing? They weren't going up anymore. They were bounded by this horizontal asymptote. And it was approaching the y value 1. So we're going to say now that f of x approaches 1. All this is very important for calculus, okay? So just please ask questions. As x goes to negative infinity, what is the graph's y values approaching? 1. Also approaching 1. Like that. So here are the main differences. That now they're approaching values. Okay. As x approaches positive infinity and x goes this way, what is the graph y value approaching? We saw that it was getting really small, right? And it was approaching 0. And then as x goes to negative infinity, same thing. F of x is approaching 0. So again, this is the new. All right, and please label this on your let's label this on your notes here. So this here is called the vertical asymptote with a T. So, and you have to write either X or Y. If you write Y incorrectly, you're going to get it wrong, okay? Because it's crossing at X equals 2. Okay, so all 3 of these have a vertical asymptote at x equals 2. But unlike this one, these 2 have also something called a horizontal asymptote. But here, it's the line y equals 1, versus here, I'm going to shorthand it and call it HA for horizontal asymptote, is at y equals 0. Okay. So how does the horizontal asymptote of these graphs affect the end behavior of the graphs?
It doesn't allow it to cross the whole thing. The horizontal ones are when they're
kind of. We're gonna look at other examples. So a graph cannot cross the vertical asymptote because of the whole domain issue. But we're gonna see with more examples that it's possible for a graph to cross the horizontal asymptote. It's just, if it crosses it, it needs to return to it because of the end behavior. Okay? So for a vertical, it cannot cross it. We'll see, that has to do with the domain. For the horizontal asymptote, it's not describing what's happening in like the center part of the graph. It cares about what happens as x goes towards infinity or negative. So it could cross it multiple times, but eventually it has to approach it. Okay, that's the big like misconception students have going into calc. So like, but it can never cross the horizontal. It can't. It's just saying that eventually the graph gravitates to y equals 1.
Does that mean there's a point where it will stop crossing the horizontal?
Correct. No, not necessarily. It can continuously just go like this. Like that. You'll look at like the craziest graphs when you get to calc. Yes. So there's graphs that do all kinds of like they start like this, and then they just eventually go like that.
So like it stops, but always ends at.
It can keep crossing it, but it still will return to one. It's like
Right.
infinitely. It just always keeps gravitating
Is
towards
it
it.
like this earthquake graphs?
Sure. Yeah. Or like when you drop a ball, like you ever played the rubber balls, and it goes doom doom. Doom. Like that. Yeah. It's kind of like it's modeling that kind of behavior. Okay. New notation. Okay. I want to now tell somebody what the graph is doing at the vertical asymptote. So as I'm getting closer to the number 2, the graph is getting closer to x equals 2, right? But what are the y values doing? They shoot up towards infinity. Okay. That's if I'm approaching 2 though, from the left side. If I'm walking towards 2 from the left, the y values shoot up. But if I'm approaching 2 from the right, now the y values are going to go down. So notice this graph does the same thing. As I approach from the left, the y values go up. As I approach from the right, the y values go down. But this one does something else. As I approach from the left, the y values go down, and as I approach from the right, the values go up. So now we have to describe new notation. I have to tell the reader, I'm going to approach 2, but from which direction am I approaching 2? And this is where the new notation comes in. When you want to say from the left, you put a little minus exponent, and that means from the left. Okay, this means from the left. From the left. As I approach 2 from the left, the y values are doing what? What are they going to approach? They just keep growing and they go to positive infinity. Now I want to say, I want to approach 2, but I want to come from the right. What do you think we do in that case? We're going to put a little plus. You put a little exponent plus symbol. And when you see that, that means from the right. This is humongously important for calculus, this notation, okay? As I approach the x value 2 from the right, here's where this is important, guys. It's from the right, not towards the right. So you're going towards 2. You're not going away from 2. That's kind of where people get confused. You're walking towards the number 2. You're approaching it from the right. What does the graph do? It goes down 10. It goes towards negative infinity. Okay. new notation, all right? As x approaches 2 from the left, what are the y values doing? They're going up. So positive infinity. As you approach 2 from the right, I'm walking towards 2, the x equaling 2 from the right, the graph is going to go down. And then the last one. Okay, let's see here. Can you guys see in the back, Chris? You see that? I don't know. Here, I'll just say it. So as you approach 2 from the left, the y values are going negative infinity. They're going down. And as you approach 2 from the right, this way, the graph goes up. So maybe let's just write this here, new notation. Just so way you guys can, if I'm approaching an x value from like this means x approaches a from the left. Versus if I write plus, we're going to say x approaches a from the right. All right, one problem and then we're done. Yeah, question.
What is again the equation? Why it's like f of x like going to the infinity instead of 1?
Oh, this one?
Mhm.
Yeah. So it's not, it's the graph doesn't shoot, see like this one. I guess I don't have it. If the graph just kept going like this, then it would be infinity. But when we graphed it on Desmos, we saw that the graph it was actually just approaching like that. It was approaching this y, the y values were like 0.9, 0.99, 0.99999, and they were approaching the y value 1. So there's a difference between f of x equaling 1 and approaching 1. Those are two conceptual things that you're going to learn to practice. Okay? Versus f of x approaching infinity, that means the graph literally will just keep going up. It's not bounded above by anything. Okay?
And about the new notation, like this one.
Here it's a similar thing. Here the graph goes like this. And what was happening is because this graph can't cross the vertical asymptote, it's like it's kind of smushed so that it forces it to just keep going like this all the way up. Okay, guys, this is what I want you to do. I want you guys to go on Desmos. This will be our last exercise of the day. So graph f of x equaling 2x plus 1 over x plus 1 on Desmos, or a graphic calculator, whichever one you have. And then I want you to practice all this new stuff we did. So I want you to find and label the vertical asymptote, I'm calling it VA, horizontal asymptote, the end behavior. Oh, and the behavior as you approach the vertical asymptote with the new notation, which is not. So on your notes, graph, use Desmos to help you sketch a graph of this. Try to label any intercepts as clearly as you can. And then label the vertical asymptote, kind of the way we did it here. Label horizontal asymptotes the way we did it here. And then label it with all this new notation that we just did. Okay? Can you see that, Jordan? And then just check with your group, or I can check it for you as well. Let me check this quick. What you guys are doing now. You know, need help with the graphic calculator? Yeah. Right. When you guys do the asymptotes, just do them as dashed lines, okay? That way you guys can clearly see where they're at. Put that, include that in your drawing. Hard question. Come on. So is it y equals one? Y equals -1 and x x. Press it. Press it. X equals X equals 2. X goes to infinity. See, the y value is like And then which is negative infinity. So for the ending here, no. Guys got your picture? Good, good. Okay, this, you guys gotta make sure you write the variable. So you gotta write x equals and y equals. See, so you should have some others. Yeah. Yeah. What about it? I got the horizontal and got underground. Oh, I see. Oh, you can just get it. Really not there. Like this. Right, guys, you can double check your work here.
Yeah. Right, that's what it is.
So again, what's the connection between the end behavior and the horizontal asymptote?
Oh, that is, that's the one I doesn't.
It has to approach the horizontal asymptote, okay? That's how way you know you can check that correctly. Okay, as x is approaching -1 from the left, the y values go up. And as you approach from the right, the y values go down. You should get something like that. Okay? And we'll stop there. We'll continue next week or Wednesday. Okay, we'll continue here to go off of that question that Eric asked. How can I find the asymptotes without knowing the graph? Good job, guys. Today was, I know you're tired, so thank you.